Hello, I've got an interesting Sudoku I'm going to try today. This one was recommended, and I also see that it has 100% rating on Logic Masters Germany right now, so that's you can't get any higher than 100. It also has 4 out of 5 stars for difficulty, so it's probably not going to be very easy. We'll see how it goes. Let's see. Let me pull it up here in F puzzles. So All right, rules. This one's it's called 33 Magnificent Dots by Petter Lovebrandt. That's probably the wrong way to pronounce his name, but there it is. Rules. Normal Sudoku rules apply. Cells connected by a dot must sum up to the same total as any other group of cells connected with a dot of the same color. The characters in the circles are there to differentiate the colors from each other in certain order. Okay, so the Y is just yellow and R is red, B is blue. And I think that's it. Just three colors. Yellow, red, and blue, yeah. And those of us that are colorblind appreciate when people put the letters in as well as the colors. That makes it much easier for me. So cells connected by a dot must sum. So they're kind of like XV, I guess. It's giving you the sum of the cells, but then some of them are on a corner, so I guess that's like that red one there is the sum of all 4 of these. This yellow one here. But some of them, so it's kind of like XV, but some of them are on corners and include all of the 4 cells instead of. So I guess they're kind of like a killer cage then in that sense. Sort of like that B is giving us the sum of all 4 of these, but there's overlap. I see. Because, like, for example, down here in box 7, all 4 of the blue dots include that middle cell. So, all right, let's see. How do we go about solving this? I've opened up just a little notepad window over here so that I can make some notes because this seems like the kind of puzzle where we're going to have to do that. So I guess we can go Y and R and B. So, okay, well over here we have 3 Ys. 3 sets of 2 that are all Ys. So, and then the 3 leftover cells here that aren't in part of these. This one is in a yellow, but that's not just in this cage. So I'm just looking at these 3 yellows that are only in box 4. So, well, we know the minimums and maximums for 3 cells. So the minimum is 6. The maximum is 9, 8, 24. And we know that the total of a box is 45 because the sum of 1 to 9 is 45. So 3y then, let's see, 3y. And these are all going to be less than or equal to, and I'm just going to know that because there's not a good way to write that easily. So 3y is going to be, the minimum it could be would be 45 minus 21. Because if this was 24, these would be 21. And if this was 6, these would be 39. And we know, obviously, 3y is going to have to be a multiple of 3, because y has to be an integer. So we can say, well, it could be 7 up to 13. Okay. I had to get rid of that noise. So y is between 7 and 13, which gives us quite a bit of range. So I don't know how helpful that is, but we know that much. Let's see, what else can we do? Is there any other way to limit? Well, okay, so y, there's a 4 cell y, so the minimum you can do in 4 cells is 10. So actually we can say y is between 10 and 13. Okay, so that's a little bit better. 10, 11, 12, or 13. So maybe we should look at the B with the 4 down here. So there's a bunch of overlaps. So all of this total is 45, of course, like we said. Let's see. So 4B, and then let's color these. Let's make these, how about green and purple, because we're not using those colors already. So 4B minus the greens, so let's just say, we'll call that the sum of the greens, minus the purple has to equal 45. Because, no, sorry, minus 3 purples. Because all the greens are getting double counted. You know, this top green up here is counted in this B and also in this B. But this middle one is counted in all 4 of the B's. So we need to subtract 3 purples because we have 4 purples and we only want 1. Because if you sum all of the cells one time, you get 45. So I guess we can do, well, let's see. So let's think about what the minimum the green and purples can be. Now, this one's getting triple counted. 3 purples. So the minimum all 5 of these can be is 1, 2, 3, 4, 5. But the smallest they can be would be if you triple count the 1. So that would be 2, 3, 4, and 5 out here. So 2, 3, 4, and 5 in the green is 14 plus 3 ones is 17. So the green and 3 purples is a minimum of 17. And the maximum is going to be, I mean, pretty big. 3 9s, 27 plus 8 7 6 5. It's 26 plus 27 is 53, I think. Oop. I think that's 53. Is that right? 27, 26 and 27 is 40, 53. I think it's 53. So we're doing 4B minus one of these to get to 45. So we can say 4B because you're adding the G and the 3P to 45 to balance out the equation. So it's going to be 55, 62, and 98. And since B is an integer, 4B has to be a multiple of 4. So it's actually going to be 64 and 96, which means B is between 16 and 24. That's not super helpful because that's a big range. Okay. Oh, and I suppose it's the same for R, actually. Up here, it's the same thing as B. So R and B are both going to be between 16 and 24. Here, let's put our little summary up here. R is 16 to 24. B is 16 to 24. There we go. Okay. Now, what else can we do? Oh, the B can't, no, the B can't be that big. There's 2, and R is the same way. Okay, B and R both have 2-cell versions as well. And the maximum you can make with 2 cells is 17 with 9 and 8. So these are actually 16 or 17. Now, do we know if they're different? Right over here is the only place where they really interact very much. 16, 17. No, they can't be. They can't be the same because 16 and 17 both have only one way to make them. 9 and 7, or I mean 9 and 8, 9 and 7. There's no other way to make 16 or 17. So they both need a 9. And so this is 9, right? And these are 7 or 8. So one of them's 16 and one of them's 17. Now, what does that do? We know there's a 9 in here with an 8 or a 7. So we've got a 7, 8, 9 triple across here. But we also know, I mean, we're at the low end of our range here, 16 and 17. So these can't be very big. These are going to have to be pretty small in the middles here. But I think this could still be 1 or 2 probably. I feel like it's limited to 1 or 2, but I don't know that I am completely confident enough to write that in yet. Okay, what else can we do? Does that 9 help us with anything else? With the Y's? Or no, it doesn't help us with the yellows. So maybe there's something else we can do with the yellows. Let's see. We've got another set of 3 yellows up here. So these are gonna... all right, I'm gonna abandon these colors down here. I think we know what that means. We've used that. All right, so these greens are gonna have to be the same. Not necessarily the same digits, but the same total. There's 2 of them up here. Oh, okay. That's cool. Yeah. Oh, it works both ways too. Oh, yep. Okay. So these are this is essentially 45 minus 3y, right? Here, I'm going to get rid of some of this stuff. We've already used it. So the green right now equals 45 minus 3y's. Because the whole box is 45, and there's 3y's up here. This is green. There's 3y's here. But a row and a column also sum to 45. So if the green is 45 minus 3y, then this has to be 3y. All 6 cells here. And we have 2 y's right there. So this has to be another yellow. And the same thing here. We've got 2 yellows. This whole thing has to be 45. This is 45 minus 3y. So this is 3y. This is another y. So there's a couple of sort of hidden yellow dots in here that aren't included. So, which now means we've got 3y again in the middle box, but this time one of them is a 4 cell. They're not all 2 cells. So this cell is also 45 minus 3y. The purple cell there is 45 minus 3y, and that's a single cell. So now G has to be 6, 7, 8, or 9. 6, 7, 8, or 9. And we know 3y is a multiple of 3. So in fact, it has to be 6 or 9 because 45 is a multiple of 3. So you're going to have to subtract a multiple of 3. So you end up with, I mean, G has to be a multiple of 3 because you're taking a multiple of 3 minus a multiple of 3. You're going to end up with a multiple of 3. So G has to be a multiple of 3. So it's 6 or 9, which means Y is now, let's see, if it was 6, you'd have 39. So Y would be 13. If you have 9, it's 36. So Y is 12. So Y is 12 or 13. We're getting this narrowed down slowly but surely. So if yellow is 12, then purple is 9. If yellow is 13, purple is 6. 12 and 13. Well, 12 would need, they both need a 1. 12 or 13, you have to have a 1. Because the minimum you can do without a 1 is 14. But I think you can do 13 without a 2, right? 1 and 3. 1, 3, 4, 5 is 13, yeah. So you can do it without a 2. If if you had if it was 12, you would need a 1 and a 2 in here. Oh, but there's the overlap. I was going to say you'd have to have a 1 and a 2 over here. And you can't have a 1 or a 2 in here because this is, 12 or 13. You can't have a 1 or a 2. But there's this one. Because they get a share one. They don't have 4, unique. They get to share a digit. Well, this is going to be... Okay, if it's 12, then it's 9. So these are 3s. If it's 13, then it's 6. These would be 7s. So this is 6 or 9 as well. So these two are going to be the same, and these two are going to be the same. Either way, there's a 1 and a 2 in here and up here. Because you can't put a 1 or a 2 in a 12 or 13 in 2 cells. So this is 1, 2, 3 or 1, 2, 6 actually. And it has to have a 1 and a 2. Um, So what do we do now? Maybe we do need to come back over here. So I think this has to be 1 or 2, right? If this is 3, then you can do 1, 2, 4, 5, which would be 12, plus 3 threes is 21. So that's the amount, 45 of, so 45 and 21 is 66. 16, 60, 17, 17 times 4 is 68. Okay, if it's 17, then we have 68 minus the middle, 3 middles. If that's 3, that's minus 9 minus the 1, 2, 4, 5, which is 12. That's going to be 59, 47. We need to subtract 2 more. So you could do that actually. You could put a 3 in the middle. You just have to put, like 1, 2, 4, 7 or something on the outside here. So we don't know what the middle cell is here. We know there's a 9 down here, and it's got to be on the outside. You can't put a 9 in the middle, in the overlap here. You'd be subtracting too much. It's 9. 9. This is 9, 8 or 9, 7. And I don't have anything that really connects the yellow with the blue or the red at this point. So maybe that's what we need. So if the blue is 9, 8, whatever the blue is, both of those are down here. Nine, 8 or 9, 7. Okay, what about up here? What's this cell? So we know this is 12 or 13 and this is 16 or 17. So if this is, let's just go with the minimum. If this is 12 and that's 16, that's 24 and 16 is 40. So this would be 5. The maximum is 13 and 13, which is 26, plus 17 is 43. So this is 2, 3, 4, or 5. That doesn't seem helpful. I know there's these Y's up here with the R's, but not seeing how that helps. We've got another one of these 3 Y's up here, so these 3 also equal the same. There's only 2 of them here. So what can we do here? What can we do? There has to be a 7 or 8 down here, but I think we decided there could be a 7 here, right? If we had 3s and 1, 2, 4, 7. If I did the math right, that would be 68 minus... Here, I'm just going to write, just to help me. If I do that, that's... If this is 17, that's 68 minus 3 3's, which is 9. That gives us down to 59. And this is 14, which gets us to 45. Yeah. So we can put a 7 here. I was thinking maybe these two had to be the... If it's the 8... Oh, but that only works if blue is 17. And if blue is 17, then it's 9 and 8. And these would have to be 9 and 8. So these are going to be 9 and 7 or 8, the same as these up here. Because whatever's in those has to be in this bottom row. Because the only way it can be a 7 is if blue is 17, in which case 9, 8, 9, 8. You could still have a 7 here. I mean, this could be 9, 7, 8. But whatever's in these is definitely in these two. Does that do anything for us? All right, I'm going to come back to this. If this is 12, is there something with the 4 here, the 16 or 17? How do you make 16 and 17? Because there's not too many ways to make 16 and 17, right? So 1, 2, 3, 4, 5. You know what? We're gonna do the cheating thing and look up a list. Because there's a lot of options. Okay. You definitely have to have a 1 or a 2. But we already knew that there was a 1 and a 1 in here anyway. There's definitely a 1 in here. Oh. Because there's a 1 here and a 1 down here, and it's definitely up here. 7, 8. So what's... Let's see, this is either 16... Oh, you know what? These three have to equal r minus 7 or 8, right? But this one is r minus 7 or 8. So these have to actually sum to 9. And no matter what, whether this is 7 or 8, these three equal 9. Because they have to be the same as that. And so there's definitely a 1 or a 2 in there. Come on. If this was 6, 7, that would have to be 8. 7. 7. This would be 9, 8. 6, 7, 8. So 3 and 6 are already taken. So these are 4, 5, 7, 8, 9. Yeah, I don't see how that helps though. Because this is 6, 7, then these could be 5, 8 or 5 or 4, 9. If this is 9 and 3, this could be 4, 8 or 5, 7. And these are the same way. Oh, so there's definitely a 1, 2, 3 in here, isn't there? Because the only way you can have a 3 on a yellow is if the yellow is 13 or is 12. But if it's 12, then you've got 3's here. And so there's definitely a 1, 2, and 3 in here. So it's either 1, 2, 3, 6 or 1, 2, 3, 7. It's either 6 and this is 9 and 3 with 5, 7 and 4, 8. Or it's 1, 2, 3, 7. And this is 6 and 7, and these are 4, 9, and 5, 8. Well, this one can't be 9. We know that. 1, 2, 3, 4, 5, 6. This could be 1. I mean, 2. 9 just has too many options. If it was 7 or 8 or something, then that would help because we'd know there had to be a 1 in there, but... Where is the key thing that I'm missing? There's something that I'm missing here. Okay, what's the... Well, this is 4 or 5. So it has to be because we had that 7, 8, 9 triple across here. So this has to be 7 or 8 or 9, but it can't be 9. So this is 7, 5, 8, 4. Oh, it can still be 8, 5. For a second, I thought it couldn't be 13. Because it can't be 9 and 4, because we've already got our 9 down here. Well, and there's a 9 in here. So, oh, wait. Wait. Is that... Let me make sure I didn't make a mistake. I think I might have just had a breakthrough. Okay, 4. This can't be... The 1 and 2 are for sure up here with either 3 or 6. If it's 1, 2, 6, this is a 9. If it's 1, 2, 3, this is a 6. So there's definitely a 6 in one of those two. So this can't be 6. It can't be 7, 8, or 9 because we've got 7, 8, and 9 here. And it can't be 3 because it would have to be with 9 if it was 12. So the only options here are 4, 8, or 5, 7, or 5, 8. But that 7, 8 gives us 7, 8, and 9 triple, which means that's a 3. Oh, wow. Which means this is 9. So yellow is now 12. I think that works. So yellow is 12, which means this is 1, 2, 3, 6. This is 1, 2, 6. This one is the same way. 1, 2, 6. We have 4, 8, and 5, 7 in some order here. Okay. So 4, 8, and 5, 7. So this is not 9. So we know yellow is 12. This one's 9. Yellow is 12. Yellow is 12. So what does that tell us up here? Anything? Oh, we know these are the same 1, 2, 6. Because that has to equal 9. We know there can't be a 3 here. These are now 12, so this is 24. So now the total here is 24 plus 16 or 17, which is 40 or 41. 24 plus 16 is 40, 20, 70, 41. Yeah, so this has to be 4 or 5. And this has a 4 or a 5 in it because it's either 4, 8 or 5, 7. So there's 4 and 5. 4 and 5 are gone. So we can have 1, 2, 6, 7, 8 for our options here. And it's got to be 16 or 17. So you got to have the 1 and the 2. 3. So we need 13 or 14. So then it's 6, 7 or 6, 8. So there's definitely a 1, 2, 6 in here with a 7 or 8. And yeah, and this is 4, 8 or 5, 7. So the 7 or 8 is going to go with the 4 or 5 there. Yeah. So we still don't know if that's 16 or 17. That's what I need to figure out. So, oh man, there's got to be a way to figure out the 16 and the 17 there. If this is 8, 7, so these two are the same. But do we know anything here yet? Don't think we know what this is. And, you know, this is 12, but it doesn't necessarily have to be 1, 2, 4, 5, because you could have a repeated digit here. Because at first I was about to say this can't be 1, 2, 3, 6, because there's no 1, 2, 3, or 6 in there, but we could have a repeated digit across here, or even across here. Because they're not actually killer cages, they're just... It's just the sum of these. Let's see, so what? Come on. Well, there's a 9 up here. But it could be here with a 3. Let's put 3 up there. These cannot be 9. Oh, these can't be 9 and 3 because the 9 and the 3 are removed from both of those. So these have to be 4, 8, and 5, 7. Which means what? Which means... has to be a 9 over here. Don't think the 9... I don't think the 9 can be there because it's going to be too big. That's going to give us a 9 right here because this one is the double counted one. So this is 1, 2, 3, and 6 through here. There's no way you can put a 6 in the middle. You could put a 3 in the middle, but... 1, 2, 3, 6, 4, 5, 7... Oh! We have a 4, 5, 7, 8... this one can't be 3. But we have a 4, 5, 7, 8 quadruple in the column. That's weird. So we have a 1, 2, 6 here, which tells us that our 9 is 1, 2, 6. Because once you have 2 of them, 1, 2, 1, 6, or 2, 6, the other one is forced. So this is 1, 2, 6. So these are 3, 4, and 5. That one can't be 3. So 3, 4, 5. So this can't be 4, 5. So this one then can't be 7, 8. Come on. 4, 5. Oh, so we have a 4, 5 pair. What else can we do? Man, we're making good progress. We have a 1, 2, 3, 6 quadruple in this area. So 4, 5, 7, 8. Or 9, I guess, but yeah, that could still be 9. Because you could have a 3 in one of these, couldn't you? Oh, the 3, 4, 5 though. This can't be 3. So I think the 3 is in the middle. 3 is in the middle, which means that's got to be the 17, right? This can't be 16 with a 3 in the middle because 16 times 4 is 64. You'd be subtracting 9. You're already down to 55. So you need to have 10 in here, and the only way to get 10 in 4 cells is 1, 2, 3, 4. Yeah, so red, finally, red is 17, blue is 16. So red is 17, which makes this the 8 and the 7. This is going to be 7 and 9. And down here is going to be 7 and 9, because this one has to have, can it have 2 in the middle? You'd be subtracting 6, which would be 58. You need 13. 1, 3, 4, and 5 is 13. So it could be a 1. It's a 1 or a 2 in the middle. 1 or a 2. Okay, what about back up here? Let's see, what can we do? So we decided it was 68 minus 9, so we need to subtract... 68 minus 9 is 59, so we need to subtract 14, right? Yeah, 14. These need to equal 14. So could we have an 8? 8, we'd have, no, we can't have an 8. Can we have 7? We'd have to have 7, which would be 1, 2, 4. Yeah, so 1, 2, 4, 7 would work. 1, 2, 4, 7. How else can we make 14? Oh, well, we've already got now a 4, 5, 7 triple here, so this can't be 7. 1, 2, 6. So there's definitely an. Oh, there's no 8 here. There's no 8 because we have the 8 here now. So 7 and 8 are definitely over here. We have a 1, 2, 6 triple now. There's a 7 or an 8. Oh, yep, that doesn't really give us anything new, does it? Okay, this could be 1, 2, 4, 7. Could it be... Could have a 6. We need it to be 14. 6. You could have 1, 2, 5, 6. No, you can't, because you can't have a 6, because if we have a 6 in one of these, then you could only have 1. Yeah, because that's also where your 1s and 2s are. So you can't have a 6 in here. So this is a 6 up top. These are not 6. Now, this can't be 4, because remember, these are yellows. These have to be 12. So if you can't have an 8, you can't have a 4. So one of these has to be a 4. So we've got 1, 2, and 4, which is 7. The other one has to be 7, so we have 14 total. So these are not 7. Now we've got our 5, 7, 4, 8 situation again here. But this 4, 7 pair is going to give us a 5, 7, 4. This is 1. Oh, and well, we should have known that because we already know what R is. That's right. It's 17, so it has to be 1, 2, 6, 8. Okay. So it has to be a 6 here, so this can't be 6. 1, 2, 8, 3, 4, 5. Okay. Now this one can't be 4. We've used our 5, 7 here, so that's the 4, 8. So this one is 5, 7, which means this is 4, 8. This is, so 12. Oh, this can't be the 9 because this would have to be 3. So this has to be the 7 with 5, 9. And 5, this can't be 5 or 7. This can't be 9. This can't be 6. Oh, we have a 1, 2 pair here, so this is 6. Now, what can we do? This can't be 6. So we've got. We do anything down here? Oh, this can't be 4. So this one can't be 5. Got 3, 4, 5. We've got our 7, 9 pair here. 1, 2. 1, 2, 3, 4, 6. Can't be 8. Can that be 6? I don't know. That might be too high, but well, let's see. We got 3 and 4. So again, 1, 2, 6. Big surprise, right? Oh, we got 1, 2, 6 triple here though. So this can't be. This is a 3 or a 4. Oh, okay. Interesting. Can that be as big as 4? I suppose it would have to be able to be because this could be 1 and 2, 3, 4, 5, and yeah. So 7. It's 9 up here. Is that an issue if this is 9, 3 or that's 9, 3? Don't think so. Okay, 1, 2, 3, 6. So these are 4, 5, 7, 8, 9. Got a 1 and 2 up here. This could still be 9 and this could be 3 and 9. Or 4, 8, or 5, 7. This one could be 3 or 9. Come on. This needs to be 17. This is as much as 9, as little as 3. Oh, this can't be 1 and 2. Can it be 1 and 3? Oh yeah, it could be 1 and 2. Sure it could. Because this would be 14. That can be 14. Okay, never mind. Oh, what am I missing? There's too many things going on here. Oh, so this is 9 and it needs to be 17. Yes, so this has to be. I was so focused on the cumulative thing of the box, I didn't look at the individual ones. So these two are 9 and this 4 need to be 17. So this has to be 8, which has to be 7 and 1, which gives us 4, 8, 7, 5, 2. So this is not 2 down here. So this is 2, which means this is not 2. So these are not 2. That's 1 and 6. So this is 2 and 8. 1, 6, 2, 8. 5, 7. So these can't be 5, 7. These are either 4, 8 or 3, 9. Oh, it has to be 4, 8 because the 8 and the 4 here rule out 4, 8 as options for these y's. So this one has to be 4, 8, which means this one is 9, this is 3, these are 5 and 7, so this is also 5 and 7. These are going to be 1, 2, 6, not surprisingly. And I have to have a 6. This is going to be 3, 9. So these are 1, 2, 6. These can't be 3, so we definitely have a 3 in here. 4, 8. Definitely have a 3 in here, which leaves 14. Could that be 3, 6? That would be 9, and you would have 6. I think that can work. I think you can do. No, you can't do 6 because you'd have to have a 1 or a 2. If these are 3 and 6, that's 9, and total is 17. Oh no, this is 8 then. I can't do math. 3 and 6 would mean 8, and you could do 3 and 3, 5. There. Okay, what are these? These are going to be 1, 2, 3, 4, 5, 6. 2, 3, 5, 6. Okay. 4 and 8. Is there any? Yeah, this 4, 8 seemingly deadly pattern is going to be fixed by this extra yellow one here. 6. There's definitely a 3 here. This is turning into a long video. This one can't be 4, 8. So, but the 4, 8 could still be over here if it was 4 and 8. Or the 4, 8 could be here. But this is 3, 9 or 5, 7. So this 1, 2, 6, 1, 2. So there's definitely an 8 up here, and it can't be on the middle. This can't be 3. There's a 3 down here and a 3 over here. Probably missing something obvious. I felt like once I got the numbers and stuff, it was all gonna fall apart, but does there have to be a 4 in here? What if you didn't have a 4? If you had a 1 and then you had 2, 3, 5, 6, you'd have 64 minus, if it was 1, you'd have minus 3. 61, you need to subtract 16 more. Could you do 2, 3, 5, 6? Yeah, you could. You could, and then you wouldn't have to have a 4 in there. So 64 minus 3 or 64 minus 6, which I know is easy, but I'm just going to write it in so I can stop thinking about it. So it's either 61 or 58. And so then we need to subtract 16 or 13. So these 4 have to be 16 or 13. If this is 1, these need to be 16, which would be what? 2, 3, 5, 6. So it'd have to be 2, 3, 5, and 6. So if it's 1, then it's 2, 3, 5, and 6. If it's 2, then we need 13 out here. Which would be 1, 3, 4, 5. Two, 3, 5, 6. This would have to be 3. These would be 2, 5, and 6. It's 1, 3, 4, 5. This is a 2. 3, 4, yeah. So 1, 2, 3, and 5 are definitely in this middle section. Because 2, 3, 5 with 1, or 1, 3, 5 with 2. So then it's 4 or 6. So this is 4 or 6 with 8. Wish I knew if that was 8, 4, because then we could make this a 6 and we'd know what was going on. So 6, 1, 2, 3, 8. 8 can be in either one of those. What am I missing? What am I missing? I'm missing something. Probably something obvious. We've done the yellows, the reds. We've done this red. We've done red, blue, blue, yellow. Got that. Well, there's definitely a 2 up there, so this can't be 2. With a 1 or a 6. So this, the only way this can be a 1 is if that's 2. And then we'd have 1, 3, 4, 5. 3, 4, 5. These would be 3, 5. This would be 4. So that would be, come on. What's in here? This could be 4, 8 or 5, 7. And this one can be, excuse me, 9 and 3, 4, 8. It can be 5 and 7. It has lots of options. This can't be 9 and 3. This can't be 9 and 3 because then it would eliminate both options there. So the 9, 3 has to be the top here. This has to be 3, 9. Which means this is not 3, so the 3 is here. Okay, which means what? Okay, we've got a 3 here. So this needs to be 14. Minimum this can be is 4. It obviously can't be 4. So if this is 1, can this be... If this is 3, these need to be 14, right? 14. It's 11 minus 1. If this is 3, minus 2, 9. No, this can't be 3 unless this is 6. But it could be 9 with a 1 or a 2. Right? 3, 14 minus 9 would be 5. Yeah, you could do 9 with a 1 and a 4 here. So, what about down here? This one is only 12. We've got a 3. Oh, so this can't be 8. Because that would be 11. Yeah, so this is a 4. 4, 8. That gives us the 8 and the 4 up there. Okay. Something. So now we've got 7. These need to be 5. So they've got to be 4 and 1. So this is 8. This is going to be 5, 7. So that's going to give us the 9 and the 7. This is not 5. This is not 5 or 7. So that's 4, 8. This one's not 4. This one's not 8. That 1 gives us, gives us the 2 and the 1 and the 2. So these are not 2. So now these are 7, which means these need to be 10, so they have to be 7 and 3. 5, 7, 5. The 8 here is going to give us the 2 and the 8 over there. And that 2 can't be there. This one can't be 2. This can't be 4. Now, what do we do next? This can't be the 7. The 7 down here gives us the 5 and the 7 here. It's going to give us an 8 and a 4. And for the 7. And so that can't be 4. So now we have 6, 8. These are not 6. So these have to be 1, 3, 4, 5 with a 2 in the middle. And that 6 makes that a 1, 2 pair, which gives us the 6 there. And come on. Oh, we've got 16 here now, so that has to be a 1 to finish 17 for the red. 6, 2, 6, 1. It's going to be 2 and 1. This can't be 1. The 2 there gives us the 6 and the 2, which will give us 1 and 6. And that 6 is going to give us the 8 and the 6. And we have a 1, 3, 5 triple. So this is 6 and 1. And oh, and of course, I'm doing it again, just like I did with the reds up here. I'm looking at the blues as a total, not individuals. So we have 11 and we need 16, so these have to be 5. So this is 1 and 4, 5, 3. It's going to give us the 3 and the 9 and 3 and 5 and 4. Oh, almost made it under an hour. So close. 17 seconds. Yeah, I should have been under an hour. There was a few things that I was a little slow on there. But all right, there you go. That was 33 Magnificent Dots by Petter Lovebrandt. I think it's called Petter. That was a fun puzzle. I enjoyed that. That was it was interesting how at first it seemed like there was so many options for all of the letters, and then as we started narrowing it down, it quickly became there was only 2 options, and then we just had to find the right combination of things. And this idea with these yellows here is really cool. They could have given us a yellow dot in here, but by leaving it, for us to kind of intuit that there was another yellow in here, that was a neat idea. Very cool. All right, I hope you guys enjoyed that puzzle, and see you again soon.